Problems from web work on section 2-3. Problem 1. Fx equals square root 70. That's a number. That's a real number. There is no x in my expression. So that's called constant function. Derivative of constant function is 0. No matter what the real number, derivative is 0. Next. Differentiate. Fx equals 6 over 7 x to the power 8. Notice 6 over 7 is a constant being multiplied to a power. So 6 over 7 stays out. 6 over 7 stays out. Now I'm going to differentiate x to the 8. Power comes down and x loses one power. So the power reduces by 1. Alright. Remember, the parenthesis is important. If there were no parenthesis, then you have 78. You understand? So 6 over 7 times 8 x to the power 7. Okay. Next. So that's how it looks like. Right? Next. Now f5 over x to the 6. Find the derivative. It is over, so it might help to rewrite this, right? So fx is given to be a fraction 5 over x to the 6. X to the 6. Okay? Notice you can write it as 5 x to the power negative 6. Okay? You could use quotient rule, but quotient rule is sometimes more complicated. So this is easier to play with. So derivative, well, the power comes down. So 5 times negative 6, and the power is reduced by 1. So in other words, negative 6 minus 1. You see? Negative 6 minus 1 is negative 7. That's your derivative. So let's write this carefully. Okay. You have 5 times negative 6 x to the power, because there are two keys to be hit. You have negative 7. Okay. Two characters. So write it in parentheses. If you don't have parentheses, power applies only to the negative, first character. All right. Next one. Fx equals square root of 9x. All right. So this is the third question. Fx is square root. Inside is 9x. So what is this? This means square root 9 is 3, and square root x can be written as x power 1 over 2. You see? So what is f prime x? 3 is a constant, 3 stays put, times power comes down 1 over 2, times power is reduced by half. So x power 1 over 2 minus 1. Alright. So if you simplify, this is the fraction. 3 times 1 over 2 is 3 over 2. And x power negative half. Okay. Half minus 1 is negative half. So first derivative is 3 over 2 times x to the power, don't forget parentheses, negative 1 over 2. Alright, so make sure 3 over 2 is in parentheses. If you didn't have the parentheses there, then you have 2x in the denominator. 2x power whatever in the denominator. Be careful. So 3 over 2 and then x to the power negative half. So what's the story? If I'm asked, so this was the derivative. If I'm asked to find the derivative at 2, all that means is I have to replace that x by 2. No need to calculate anything. Simply write, replace x by 2. Okay? And that's it. WebWork does the calculation for you. You don't have to find that value. Next. Here, what does this mean? Right? So this is, this is derivative function, definition, right? Limit x approaching 1 of the fraction x to the, power 100 minus 1 over x minus 1. Okay, this looks very similar to limit x approaching a of the fraction f of x minus f of a over x minus a. So when you put it in this fashion, x minus a. So when you write it in this fashion, you notice x is approaching 1, x is approaching a. So a has to be 1. What about fx? Fx is here. Fx should be x to the 100, right? F of x should be x to the power 100. Please check that fa is indeed 1. A being 1, f of 1, 1 to the 100 is 1. So that is correct. So what does this represent? What does this represent? This represents f prime at a. That's the definition. All right. So what does this represent? We want to find f prime at 1 because a is 1. That's what this question. All right. So first let's find f prime at x. Well, if fx is x to the 100, f prime x will be 100 x to the power 99. You see, 100 comes down, power reduces by 1, which tells me f prime at 1. I need to plug in x equals 1 equals 100 times 1 to the power 99. Well, 1 to any power is 1. So it's 100 times 1, which is a 100. That's all. So this, if you try to find the limit, it's not easy. You need to factor this and so on and so forth. Whereas here, it's a simple derivative. If you convert this to a derivative definition, then everything falls in place. Okay? So this is 100. All right. Next problem. Find the derivative of a polynomial. We go through each piece. Derivative of a polynomial. Derivative of 5x is simply 5 plus derivative of a constant is 0. So 5 plus 0. Next. Here again, this is a polynomial. Derivative. 5 times 8. So think of it. 5 times 8 is 40. X to the power 7 minus, power comes down, 4 times 5, 20. X to the power 4 minus 2 times 3, 6. X to the power 2 plus 4 times power 1, 4. X to the power 0, nothing. X to the power 0 is 1. So that's it. All right. I can rewrite this function. Okay, so we can rewrite this function. I forget the question number 8 to be 2 plus 8x to the power -1 plus 4x to the power -2. Once you rewrite it in this fashion, then you can see what happens to the derivative. Derivative of constant 0 plus 8 times power comes down and x reduces power by -1. So -1 is -2 plus 4 times power comes down and x reduces power by 1, right? So -2 minus 1 is -3. So that's your derivative. So let's write that down. 0, I don't need to write. 8 times -1 is -8. X to the power -2. Then plus 4 times -2, -8. X to the power, don't forget parenthesis, -3. That is derivative of x in terms of x. If I want derivative of 2 at 2, I replace the x by 2. Remember, now that looks like 82. So I need 8 times 2 power all that. Okay, minus 8 times 2 power all that. So remember, parenthesis 8 times all of that. So we'll continue next problem in our next video.